Orbital Gardens, this is Mission Control. We are confirming acquisition of your signal. You are live in 5, 4, 3, 2.
Hello and welcome to Gardeners of the Galaxy, the podcast for all of the sentient beings in the universe who have a passion for plants. I am Emma the Space Gardener and I will be your host as we explore gardening on Earth and beyond. We're 2 weeks into 2024 and already we've been reminded that spaceflight is hard. Astrobotics' Peregrine Mission 1, carrying the first US-built lunar lander launches the Apollo program, ran into problems shortly after reaching space. A propellant leak means that there's no chance of a soft landing on the moon, although the team is working to prolong the operational life of the spacecraft as long as possible, allowing some of the scientific payloads to collect valuable data. But while Peregrine 1 may not last as long as most people's New Year's resolutions, there's plenty to look forward to later in the year. I'm excited that 2 NASA spacecraft scheduled for launch later in the year will be carrying my name with them after I signed up online for a boarding pass. Europa Clipper, launching in October, is heading off to Jupiter to study the moon Europa. And in November, a second astrobotic launch hopes to deliver the Viper rover to the moon. And if you're hoping for something a little more plant-based, then you won't have to wait long. The Axiom 3 private astronaut mission, due to launch at the end of the month, will be carrying 4 astronauts to the International Space Station with a cargo of Turkish plant and algae experiments. What space-related happenings are you looking forward to this year? You can let me know by sending an email to earth@spacebotany.uk or by finding me on social media, and I'll pop those details in with the show notes on the website theunconventionalgardener.com. Our mission specialist for this episode is Marshall Porterfield, Professor of Biological Engineering and Space Biophysics at Purdue University. During a stint as Division Director for Space Life and Physical Sciences at NASA headquarters in Washington, D.C., Marshall oversaw the Human Research, Physical Sciences and Space Biology programs, including research and engineering assets at 6 NASA centers. He established the first open science and advanced integrated omics research programs, including NASA Gene Lab and the NASA Twin Study. Those are just some highlights from a long career in space science, and we'll be hearing more about that in just a moment. Before we get to that, I'd like to thank each and every one of you who supports the show, whether that's via a financial contribution or by sharing it with friends and colleagues. Gardeners of the Galaxy wouldn't exist without you. If you'd like to find out more about the different ways to help out, visit theunconventionalgardener.com/boosters. Hi Marshall, welcome to Gardeners of the Galaxy. It's great to have you on the show today.
Thank you, Emma. I'm really happy to be here today too.
So I'm really excited to be talking to you because you've had really quite a long career in space science now. And I was hoping that in this episode we could go on a little trip down memory lane for you and you could go back to where it all started, because you mentioned to me that you did your PhD with Mary Musgrave.
Yes, at LSU, at Louisiana State University.
So what was it that you were studying there with Mary?
I went to LSU specifically to study plants in space. I found out about her work from a friend of mine, actually my undergraduate research mentor at University of South Alabama, where I did my undergraduate. And he saw a newspaper article in the local newspaper about a professor at LSU who was doing this work at NASA. And remember, this is before the internet and before you look things up. And, you know, he found it in the newspaper and he gave that to me. And I called her up on the phone. She said, won't you come over and visit me? So I actually got in the car and drove over, to Louisiana and visit her. And, I had this idea independently that I wanted to work on plants in space. And I'd realized that NASA was going to need bioregenerative life support. We're going to have to grow food and take it with us if we're going to actually go and live in space. So I realized that, and I knew that plants would be a critical component for future human space exploration. And I saw that as a way to get involved with it. So this is like in 1990. So I started my PhD work with her in 1993.
Okay, what kind of plant experiments was she working on at that time?
She was working on plant reproduction in space. We're using a Arabidopsis as a model organism. She was trying to look at flower production, flowering, pollination, all the aspects of plant reproduction. And I was working on the root systems of those plants.
Okay, because I can't remember quite what the dates are, but Dr. Musgrave was involved with the experiments on Mir, wasn't she, where they did the complete life cycle of, I don't think it was Arabidopsis, I think it was the Wisconsin fast plants or something, wasn't it?
Yeah, we did Brassica on Mir, but we were working with the Arabidopsis in the original plant growth unit with the plant growth chambers. Some of the first hardware that was built for plant growth systems in space, and with some of the earliest plant growth experiments that were done in the shuttle era.
Was that astroculture?
It was Chromex.
Chromex. Okay, so tell me about Chromex.
Yeah, Chromex was a series of experiments that NASA initiated, and Chromex 1 and 2 were really chromosomes in space is really what they were looking at, just chromosome aberrations to see if there was any kind of radiation damage to chromosome structure. And then we were Chromex 3, 4, and 5, where we started looking at plant reproduction and other aspects of stress physiology and plant growth systems in space.
I mean, so we're talking here about the early days of the space shuttle era.
Yes.
And you worked out of Hangar L. So, I mean, Hangar L is another thing that I see in the sort of history books of that time. So what was Hangar L?
Oh, it was really amazing. So, yeah, I was so lucky because, at that time, the Controlled Ecological Life Support Program under the leadership of Bill Knott, also Ray Wheeler was one of the primary scientists. They were both mentors of mine during the time that I did my PhD, because I spent my summers as part of my NASA fellowship working out of Hangar L, and Little L, which was the building we called the Plant Space Biology Lab. And that's actually where we did some of the first work with LEDs. NASA really essentially invented the use of LEDs for plant growth. I remember the day the first blue LEDs came out of the box. And that ultimately led to the astroculture experiment, which was the first flight experiment where we used LEDs and hydroponics together in a plant growth unit in space.
Yeah. Okay, so I mean, Hangar L was also the place where they built the flight experiments, wasn't it, and got them ready to load it on the shuttle?
Yeah, that was where they did all the flight processing for flight experiments and post-processing of flight experiments after they came back. So actually all the rodent experiments, Neurolab, and all those big projects that were space shuttle era science projects were facilitated through Hangar L and Little L.
And so you look back on that time, did you have a favourite experiment that you really enjoyed either working on or seeing in action?
Oh, I don't know. I think for me, probably some of the most memorable was Chromex 5 that returned to Edwards, which is now Neil Armstrong. So the alternative landing site for the shuttle was always California. And for that flight experiment, I was the skeleton crew. Since my material processing needs were fairly small for the root system.
Right.
So the A team was at Kennedy, ready to process all the flowers and everything. And I was the backup team at Dryden. And I ended up processing that whole experiment myself because it landed out there and it was just me. And I worked so hard that day. I worked all day, and then I had all those samples. And that night they put me on a red eye, flying me from San Francisco to Orlando. I'd processed those materials. I got them in packaged and stabilized, and I flew them to Orlando. And then from there, it went to Kennedy, where the team was, Mary and the rest of the team were already there at Kennedy waiting for the flight return. So really all the rest of the post-flight processing went through the normal lab, but I had to do all that primary work out at Dryden.
Wow. A bit of a high pressure environment for you there.
Yeah. And I remember the first day we drove on base, I looked up and there was an SR-71 flying around. And then I walked out one day to take a break, and I looked up, and there was a B-2 stealth bomber just flying around. So it was really cool.
How many times did you get to see the space shuttle take off or land?
I think we saw 3 launches at different times.
Yeah, it must have been something.
Yeah, you feel the shuttle launch.
Yeah.
You feel it, like in your body.
Amazing.
It's an amazing experience. As you see the launch light up across the causeway, and a few moments later, you can actually hear it. That experience is profound.
Yeah, I really missed out on that being born British.
I think it's important for people to understand the history of what happened with the CELS program, and kind of a spin-off of the CELS program was the Bioplex, where they had taken a lot of the research that was developed through the CELS program in terms of controlled environment agriculture and high density crop production in relation to human habitation. The next step was to combine that with human habitation and actually test that. These kind of a prototype of a biohabitat. Yeah. NASA developed a platform called the Bioplex which was cut and canceled in 2004 when really all the NASA life sciences were cut as a way to realign budget so that they could pay for large projects like the Space Launch System and Orion and phase out the space shuttle and finish paying for the ISS. In the meantime, they really cut all the programs that are the future habitation, all the programs that were plant dependent in terms of bioregenerative and bioastronautics capabilities for advanced human habitation. And not only were those programs cut, but the Chinese actually were able to replicate those programs and complete them. So the NASA Bioplex became the Beijing Lunar Palace, which was completed about 2016. And they've gone on to do more studies, more complex studies looking at interaction with humans in these types of controlled environment agriculture settings and how the plants are responding. And so they have a lot of experience with operating these closed systems. They know where the problems are, and they're developing that as a platform for a lunar habitat. They have in their plans right after 2030 that they're going to be operating a habitat on the lunar surface. That's ahead of what NASA has in their published plans. So even if you look at what we have on paper, what people say they're going to do, China is ahead of us, and we just haven't responded to what they've been doing on the life sciences side. So we haven't even attempted to match the Bioplex project. So we don't have these programs. People think we have these large programs, and I think SpaceX thought that they could just pull NASA tech and plug it in and go to Mars. Well, they were surprised when they found out there was no NASA tech to plug in.
Yeah, I mean, you see a lot with SpaceX and Elon Musk about his plans for getting people to Mars, but there's absolutely nothing in his details about how they're going to survive there, feed themselves, or anything like that. You know, he doesn't think about plants at all.
On the U.S. side, we really need to invest in these habitation systems and the long line of research it's going to take in order to ultimately deliver a technology that's going to be reliable and resilient enough to plan a mission around and put people's lives into these systems.
I mean, ESA are doing some of that with the Melissa project. I mean, you don't hear much coming out of it, though.
Yeah, so, I mean, it's wonderful. Yeah, the Melissa project is really, right now, other than what the Russians are doing, we don't really know everything that they do with their programs that they've been running since the 1960s in Siberia. But they have a habitation program too, and now they're going to be teaming up and working with the Chinese on the lunar base. So now it's a Russian-Chinese lunar base. It's the most recent agreement. So together they'll be formidable because with the Russian-Soviet track record in history, going back to the 50s and 60s with everything they've done in bioregenerative habitation, we learned a lot by working with the Russians in the space station era. They developed the space station era while we went off and landed on the moon. The space race is not over until people are living on the moon.
Okay, yep, can see that. I think we're in for an interesting few years in the space plants department. Simon, if you had a crystal ball, do you think we will see plants growing on the lunar surface before the end of this decade?
They've already been growing on the lunar surface. The Chinese did it first.
Oh, it hardly counts. They had a seed sprout and then it died.
Well, it's still the first.
Yes, it didn't live very long.
Actively growing, I hope so. If it depends on what the radiation environment does with the actual biology. We ought to be able to get basic growth, but yeah, it'd be really interesting to see how well they do.
It will. Yeah. Okay, so I mean, if we come back to the present a little bit, you told me that you're working on a flight experiment, an upcoming flight experiment. Can you tell me a bit about that? Are you allowed to?
Well, we have a proposal for an Artemis landing.
Okay.
Where we're proposing to do a plant growth experiment and look at some other streamophile organisms on a lunar surface experiment that would allow us to get some return. On this mission, they're providing potential for material return.
Okay, so but I mean that's they're not thinking about them landing on the moon until sort of 2026 now, are they?
Yeah,
so,
but there's already calls for proposals and projects to be developed for that now. So
that would be really exciting if you could see that then. Yeah.
Yeah, we're really interested in what we see when we move out into deep space radiation environment.
Yeah.
Because low Earth orbit radiation is orders of magnitude lower than the type of radiation we're going to have to deal with out in what I call real outer space. So looking at radiation responses, that's really some of the keys of what we were interested in the lunar surface experiments.
Yeah. I mean, there's some massive challenges about growing plants on the moon, though, aren't there?
There's a massive challenge about keeping anything alive more than a week or two on the moon. The radiation environment will fry you out there. People don't realize that there was a study that was published recently where they went back and looked at the original Apollo crew and compared that to ISS crew who spend on average 6 months in low Earth orbit. And the Apollo crews that saw between 6 and 10 days of deep space radiation had 5 to 6 times the cardiovascular disease levels than the crew that sees 6 months in low Earth orbit. 1 day in deep space is like 2 years on the Earth.
Yeah.
So I always talk about like when we say we're going to fly people through deep space and arrive at Mars and land and have the crew do work. Imagine spending 2 years at the beach. That's 1 day in space. Yeah, I really doubt that we'll be able to send crews and allow them to stay safely at the lunar gateway for a month. I don't believe that that's possible biologically. Yeah, we're going to have to start testing shielding other than just the passive spaceship we're in.
Okay. As I said at the beginning, you've been involved with spaceflight your whole career. Did you ever have the desire to be an astronaut? Sounds like probably not now with the radiation, but did you ever want to be an astronaut?
Oh, yeah. I actually thought about when I was at headquarters applying for the astronaut corps, but ultimately I didn't have the time to actually put in the effort to, do the application process when I was working at headquarters.
Yeah.
But yeah, I thought about it. I mean, if there was some kind of expedition where I could serve as a crew member and I was healthy enough, I would go.
Okay, so assuming that you're going into space, maybe on a long duration mission, and you can take one plant with you as your personal plant, what would you choose and why?
I would take Nepenthes.
Okay.
It's a carnivorous tropical vine. It's actually a modified vine. I love these plants. I've got them in my office and out in the hall. And we actually have a project now where we're looking at understanding how the plant is positioning its pitchers.
Okay.
And it's really interesting because when the leaf grows out, it finds a place for the pitcher. And when it finally differentiates, it grows down really hard. And then when it hits this point where it wants the pitcher to be, it stops and becomes negatively gravitropic and grows up and forms that pitcher.
Okay.
So it's the whole time it's integrating light, touch, and gravity in positioning these pitchers. Yeah, I would have Nepenthes in space.
So you want to see what it does in space?
Yeah.
Because some of them are edible. There are some cultures that use them as food wrappings.
I haven't seen that, but if you think about having them, they can you can feed them nitrogen in solid forms. Essentially, if you give them traditional nitrate and ammonia to the root systems, they'll actually kill these plants because they've adapted to a lifestyle where they acquire their nitrogen and phosphate from these animal sources, these insect sources.
Yeah. You're not slightly worried that the deep space radiation is going to mutate them into something from the Little Shop of Horrors?
No, I don't think. They're not a Venus flytrap. It's totally a passive,
You think you're safe. It's not going to grow enormous and swallow the crew.
Yeah, but sometimes I get ladybugs I put them in my growth chamber because I'll get aphids in my orchids.
Yes.
And then they go over and visit the Nepenthes and they feed the Nepenthes. And I watch those ladybugs when they walk around the lips of those Nepenthes pitchers. And I think that there's something more going on in there because they not only attract the insects, but I think they make them a little bit drunk somehow. Because after a while they walk around that and all of a sudden they just like fall over. They fall in. And I'm like, what? That perfectly competent ladybug climbed up there and then fell in that cup. There must be something going on. So there's more science to be discovered from the Nepenthes. I'm sure of that.
Yeah, so maybe they will mutate and start bringing in the crew like sirens, and then you'll just find, they've all been eaten. And
There's already plenty of hazards in space already.
Okay, so no, Nepenthes, that would be interesting. I would be happy to see that in my space greenhouse.
If they would be a source of vitamin C, then they could pull their weight.
Yeah, I'm sure they could, we can manage
Maybe
that.
you feed them old hair, and then you get vitamin C back.
Okay, lovely.
Well, we need to recycle materials in space. We're actually working on right now figuring out how to grow clothing from urine. So
Yeah. And of course, there are those nepenthes that feed on rat droppings that have evolved as rat toilets.
yeah, I saw that. That's really, yeah, but that's what we need to do.
I mean, how do you encourage the rat to, I don't know.
No. I see a future now where we've engineered nepenthes to be a bio toilet. And your bathroom now is a growth chamber, and you go in there and there's this nepenthes picture. I should send you a picture of the cup of the lining of the cups around the pitcher. They're really smooth.
They are, and they roll over, don't they? They're nice rolled edge. It looks comfy. Oh God,
that's a great idea.
Gonna need some gravity for that.
Have to patent that.
Yeah, the biogenic space toilet.
What's the international patent? Yeah.
You heard it here first.
Hey,
everybody.
that's the number one problem in space besides the radiation problem is the waste management problem.
Okay. Space nepenthes. Yeah, I think that could definitely work. Marshall, it's been brilliant having you on the show and hear about some of the history of space plants research. Thank you.
Thank you, Emma. It's been really great spending this time with you. Well, we have a patent to work on, so the nepenthes toilet.
We do indeed, yeah. I can see that being a real winner. No, that was brilliant. Thank you so much.
Thank you.
Have a good day, Marshall. Bye-bye.
Bye.
Thanks again to Marshall for coming on the show and sharing some of the highlights from his fascinating career in space science. Don't forget that you can find the show notes on the website at theunconventionalgardener.com. You can also sign up to the Gardeners of the Galaxy newsletter for new episode alerts and bonus astrobotany content. That's it for this episode, so I'll hand you back to Mission Control. It's time for me to put my feet up with a film and some popcorn. Capcom, what are you screening this evening?
Orbital Gardens, this is Mission Control. We are confirming termination of your signal. Unfortunately, we have also lost your movie requests, so we have picked you The Martian and Frozen. Uplink commencing now. Mission Control out.